40 Most Amazing Things Seen by the Cassini-Huygens Spacecraft. Hello everyone, welcome to Space Explorer channel. The Cassini-Huygens mission, a collaboration between NASA, the European Space Agency, and the Italian Space Agency, provided us with an unprecedented look at the Saturn system. Over its 13-year mission, the spacecraft sent back a wealth of data and images that have helped scientists better understand the mysteries of Saturn and its moons. In this video, we will explore the 40 most fascinating finds of the Cassini-Huygens mission. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. 1. Saturn's rings. One of the most iconic images captured by the Cassini-Huygens mission are those showcasing the dazzling complexity of Saturn's rings. This extensive system, made primarily of ice particles with a smattering of rocky debris, revealed intricate structures such as gaps, waves, and braids that had never been observed in such detail before. Cassini's close passes allowed scientists to study the interactions within the rings, uncovering phenomena like the propeller-like features caused by tiny moonlets. These observations provided crucial insights into the formation and evolution of planetary ring systems, showing us that Saturn's rings are a dynamic and constantly changing environment. 2. Titan's surface. Titan, Saturn's largest moon, revealed a surprisingly Earth-like surface thanks to the Cassini-Huygens mission. With its thick atmosphere, Titan was a mystery until Cassini deployed the Huygens probe, which landed on its surface. Images and data sent back showed river channels, lakes of liquid methane and ethane, and vast dunes shaped by Titan's winds. This moon's surface, cloaked under a dense atmosphere, offers a unique glimpse into geological processes in an environment vastly different from Earth, yet strikingly similar in appearance to our own planet's geological features. 3. Enceladus geysers. The discovery of geysers erupting from Enceladus's south pole was one of the Cassini-Huygens mission's most startling findings. These powerful jets spew water vapor and ice particles from the moon's subsurface ocean into space, hinting at potential hydrothermal activity beneath its icy crust. Cassini's flybys through these plumes collected samples, providing invaluable data that suggest Enceladus has the chemical energy necessary to support microbial life. This remarkable insight into Enceladus's internal ocean and its geysers underscores the moon as one of the prime locations in our solar system for searching for signs of life beyond Earth. 4. Hexagon-shaped storm on Saturn. Among the astonishing discoveries of the Cassini-Huygens mission was Saturn's hexagon-shaped storm, a persisting atmospheric phenomenon at the planet's north pole. This six-sided jet stream, larger than Earth itself, exhibits winds racing at about 200 miles per hour. Captured in unparalleled detail by Cassini, this unique geometric feature stands out as a mesmerizing mystery of the natural world. The storm's vividly colored bands, captured in various wavelengths, highlight the dynamic and complex atmospheric conditions of Saturn, offering scientists key insights into planetary weather patterns. 5. Titan's methane lakes. Titan's methane lakes represent another of Cassini-Huygens' startling revelations, showcasing the only known body besides Earth with stable liquids on its surface. These expansive lakes and seas, primarily composed of methane and ethane, are concentrated near Titan's polar regions. The detailed imaging and radar data from Cassini revealed the depth, composition, and seasonal variations of these extraterrestrial lakes, providing clues about the moon's weather patterns, including rainfall and evaporation cycles akin to Earth's hydrological process, yet with methane playing the role of water on this distant moon. 6. Diome's wispy terrain. Diome's surface intrigued scientists with its enigmatic wispy terrain, initially believed to be ice deposits. These linear features, upon closer inspection by the Cassini-Huygens spacecraft, were revealed to be vast canyons with bright ice cliffs created by tectonic fractures. These canyons stretch hundreds of kilometers across Diome's surface, providing a stunning visual contrast against the Moon's darker regions. The discovery underscores the Moon's geologically active past and offers clues to its evolution, illustrating the dynamic processes shaping the icy bodies within the Saturn system. 7. Hyperion's sponge-like surface. Hyperion, one of Saturn's many moons, captivated scientists with its unusual sponge-like appearance. This porous surface, unlike any other in the solar system, is covered in deep, crater-like depressions that give it a distinctly spongy look. Cassini-Huygens close-up images of Hyperion allowed researchers to study these irregular features in detail, suggesting they could result from a unique combination of Hyperion's low density and its high porosity. This peculiar surface texture has significant implications for understanding the impact processes and erosional forces at work on icy bodies, providing a glimpse into the Moon's chaotic rotation and its history of collisions in the Saturn system. 8. Prometheus interaction with Saturn's F-ring. The Cassini-Huygens mission captured the intricate dance between Prometheus and Saturn's F-ring, showcasing a gravitational interaction that shapes the ring structure. Prometheus, a small moon, periodically tugs at the F-ring's particles, creating patterns known as streamers and propellers. These disturbances offer a fascinating look at the gravitational influences moons exert on ring systems, further illuminating the complex and dynamic relationships within the Saturn system. This interaction demonstrates the delicate balance of forces that maintain the ring's appearance and structure, highlighting the nuanced interplay between Saturn's moons and its rings. 9. Auroras on Saturn. The observation of auroras on Saturn stands as a captivating discovery by the Cassini-Huygens mission. These natural light displays at the planet's poles are akin to Earth's northern and southern lights, caused by solar winds interacting with the planet's magnetic field. Cassini provided stunning visuals of Saturn's auroras, displaying them in ultraviolet wavelengths and revealing dynamic behaviors tied to the solar wind and the planet's own atmospheric conditions. This phenomenon offered an extraordinary opportunity to study the interaction between the Sun and Saturn's magnetic environment, further enriching our understanding of space weather processes across the solar system. 10. Iapetus two-toned surface. One of the most striking discoveries by the Cassini-Huygens mission was the dramatic contrast in color across Iapetus' surface. This moon exhibits a unique dichotomy, with one hemisphere cloaked in bright ice and the other in dark material. Scientists suggest this variation may result from the accumulation of debris from other moons or the redistribution of its own ice and dust. 11. Titan's sand dunes. The Cassini-Huygens mission unveiled the vast expanses of sand dunes on Titan, Saturn's largest moon. Stretching for hundreds of kilometers, these dunes are made of hydrocarbon grains, sculpted by Titan's wind. Their discovery was pivotal in understanding the dynamic surface and climate conditions of Titan, revealing similarities to Earth's own desert landscapes, despite the vastly different temperatures and materials. 12. Titan's methane rain. Among the fascinating findings from the Cassini-Huygens mission was the observation of methane rain on Titan. This phenomenon contributes to the Moon's complex hydrological cycle, akin to Earth's water cycle, but with methane taking the place of water. The methane rain feeds Titan's rivers and lakes, playing a crucial role in shaping its surface and atmospheric processes. 13. Rhea's bright craters. Rhea's surface is punctuated by bright, fresh craters that starkly contrast against its darker background. These craters, illuminated by the sun, reveal the Moon's geologically active past. Their bright appearance is attributed to the exposure of cleaner ice from beneath Rhea's surface, providing clues to the Moon's compositional layers and impact history. 14. Titan's complex atmosphere. Titan's atmosphere, denser than that of any other moon in the solar system, is composed mainly of nitrogen with traces of methane and hydrogen. Its dense, orange haze layers, resulting from complex photochemical reactions driven by sunlight, play a crucial role in Titan's climate and methane cycle, influencing both the moon's weather and surface features. 15. Pandora's sculpting of Saturn's F-ring. Pandora, one of Saturn's moons, plays a fascinating role in shaping the planet's delicate F-ring. Its gravitational influence creates kinks and braids within the ring, showcasing a dynamic interplay between moon and particles. This interaction not only demonstrates Pandora's influence, but also highlights the intricate relationships within Saturn's rings and moons, adding a layer of complexity to our understanding of these celestial bodies. 16. Mimas' giant Herschel crater. Mimas is distinguished by the Herschel crater, a massive impact feature that spans 1/3 of the moon's diameter. This crater, with its prominent central peak, gives Mimas a resemblance to the iconic Death Star from Star Wars. The size and depth of Herschel crater highlight the moon's geologic history and the violent impacts that have shaped the Saturnian moons. 17. Saturn's mini-moons. Cassini-Huygens revealed a fascinating array of mini-moons orbiting Saturn. These tiny celestial bodies, some just a few kilometers across, dance through the gaps and edges of Saturn's rings. Their discovery illuminates the intricate gravitational interactions that sculpt the ring system, hinting at a dynamic and evolving Saturnian environment. 18. Tethys Ithaca Chasma. Tethys Ithaca Chasma is a staggering canyon that stretches over 3/4 of the moon's circumference. This enormous rift suggests a history of intense internal activity, likely caused by the freezing and expansion of water within its interior. The chasma provides insight into the geological processes that have shaped Tethys, offering a glimpse into the moon's tumultuous past. 19. Rings, moonlets, and propellers. The Cassini-Huygens mission unveiled small moonlets within Saturn's rings, creating distinctive propeller-shaped gaps as they orbit. These structures provide insight into the formation and dynamic interactions of Saturn's rings, showcasing the delicate balance between gravitational forces and the movement of ring particles. 20. Janus and Epimetheus dance. Janus and Epimetheus share a unique orbital relationship around Saturn, engaging in what can be described as a cosmic dance. Every 4 years, they swap orbits due to their gravitational interaction, showcasing a rare and intricate celestial ballet. This dynamic exchange highlights the complexities of Saturn's moon system and the gravitational forces at play. 21. Atlas Equatorial Ridge. One of the most visually striking features discovered by the Cassini-Huygens mission is the equatorial ridge on Saturn's moon Atlas. This unique geological phenomenon, reminiscent of a flying saucer, took the scientific community by surprise. The ridge circles the moon's equator, giving it a distinct, disc-like appearance that distinguishes Atlas from other celestial bodies in the solar system. This feature was first observed in detail during Cassini's close flybys of the moon, revealing a ridge that rises unexpectedly high relative to the moon's size. The equatorial ridge on Atlas spans up to 10 kilometers in width and reaches heights of approximately 2 kilometers, a significant proportion considering the moon's overall diameter is just about 30 kilometers. The formation of this ridge has been a topic of much debate and speculation among scientists. Current theories suggest it could be the result of accretion of material from Saturn's rings, pointing to a fascinating interaction between the moon and the planet's iconic ring system. The discovery of Atlas Equatorial Ridge not only highlights the diverse geological features present within our solar system, but also opens up new questions about the processes shaping these celestial bodies. The Cassini-Huygens mission, through its detailed study of Atlas and other Saturnian moons, has provided invaluable insights into the dynamic and complex nature of the Saturn system, revealing wonders that challenge our understanding of planetary science. 22. Enceladus Tiger Stripes. The exploration of Saturn's magnetosphere by the Cassini-Huygens spacecraft unveiled the complex and dynamic nature of the gas giant's magnetic environment. Unlike anything found around Earth, Saturn's magnetosphere is a vast region of space, dominated by the planet's magnetic field that encases not only Saturn, but many of its moons and its iconic ring system. Cassini's comprehensive observations have provided unprecedented insights into the interactions between Saturn's atmosphere, its rings, and the solar wind. One of the key findings from Cassini-Huygens pertains to the phenomenon known as Saturn kilometric radiation, SKR, electromagnetic emissions similar to Earth's auroras, which paint a vivid picture of the electromagnetic processes at work within Saturn's magnetosphere. These emissions revealed how Saturn's rapid rotation and the solar wind influenced the planet's magnetic field, creating variations in radio emissions that were more complex and variable than previously thought. Additionally, Cassini-Huygens detected small particles being accelerated to high energies within the magnetosphere, contributing to our understanding of the energetic particles trapped by Saturn's magnetic field. These particles interact with the planet's rings and moons, leading to fascinating chemical reactions and physical processes, including the erosion and alteration of moon surfaces and the dynamics of ring material. The spacecraft's journey through Saturn's magnetosphere also shed light on the unique interaction between Enceladus and the magnetic field. The moon's icy geysers, discovered by Cassini, feed material into Saturn's magnetosphere, creating a complex feedback loop that affects the planet's auroral regions. This intricate dance between moon, rings, and magnetosphere underscores the interconnectedness of Saturn's space environment, illustrating a level of complexity that has fascinated scientists and deepened our understanding of planetary magnetospheres. 23. Titan's methane cycle. Titan's methane cycle represents one of the most fascinating hydrological systems discovered beyond Earth, distinctively driven by methane rather than water. Cassini-Huygens' exploration of Titan, Saturn's largest moon, unveiled this alien cycle, where methane exists in liquid form on the moon's surface and as a gas in its atmosphere. The cycle mirrors Earth's water cycle, involving evaporation, cloud formation, precipitation, and possibly methane runoff into hydrocarbon lakes and seas, showcasing an incredible example of extraterrestrial climatology. Through detailed observations, Cassini-Huygens observed clouds of methane moving through Titan's dense, nitrogen-rich atmosphere and documented rainfalls of methane, filling vast lakes and seas primarily located in the moon's polar regions. This cycle is crucial for understanding Titan's geologic and atmospheric dynamics, indicating active weather systems and seasonal changes on the moon. The presence of such a cycle suggests that Titan's surface and atmosphere interact in complex ways, driven by solar energy and possibly internal heat, to maintain this cycle of methane. The exploration also hinted at the existence of an underground source or reservoir of liquid hydrocarbons, feeding the surface lakes and replenishing methane lost to the atmosphere through evaporation. This subsurface interaction potentially adds another layer of complexity to Titan's methane cycle, hinting at geological processes that might resemble Earth's hydrogeological cycles, yet composed of entirely different substances. Cassini-Huygens' findings on Titan's methane cycle have not only expanded our knowledge of the moon's environmental processes, but also challenged our understanding of planetary science, demonstrating the diverse ways in which similar hydrological-like cycles can occur in the cold outer reaches of the solar system. 24. Pan's equatorial ridge. Pan's equatorial ridge, much like the feature observed on the moon Atlas, presents another astonishing geological characteristic uncovered by the Cassini-Huygens mission. This ridge encircles the equator of Pan, one of Saturn's innermost moons, and imparts to it an appearance akin to that of a walnut. The formation is so prominent that it significantly alters the moon's overall shape, emphasizing the diversity and unexpected nature of celestial body topographies within the Saturn system. The ridge on Pan is believed to have formed through a process similar to that of Atlas, accumulating material from Saturn's rings. However, the specifics of its formation and evolution offer a unique case study, showcasing the intricate relationship between Saturn and its moons. Cassini's detailed imaging revealed the sharp contrast in texture between the ridge and the rest of Pan's surface, suggesting a dynamic history of accretion. These observations have led scientists to ponder the effects of Saturn's gravitational pull on the distribution and behavior of ring particles, as well as the potential for similar features to exist on other moons within the solar system. This discovery underscores the importance of the Cassini-Huygens mission in expanding our understanding of the Saturnian moons. By revealing the peculiarities of Pan's equatorial ridge, Cassini has further illustrated the complex processes that shape our solar system's celestial bodies, enriching the dialogue within the scientific community about planetary formation and evolution. 25. Titan's hydrocarbon lakes and seas. Among the marvels unveiled by Cassini-Huygens, Titan's hydrocarbon lakes and seas stand out as one of the most intriguing features. This moon, shrouded in a thick atmosphere, hosts expansive lakes and seas not of water, but of liquid methane and ethane. These extraterrestrial bodies of liquid, captured in breathtaking clarity by Cassini, offer a rare glimpse into the complex climate and geology of Titan. The presence of these liquid hydrocarbons hints at a cycle akin to Earth's water cycle, but in a frigid environment where water ice forms the bedrock. Cassini's images of these lakes and seas have opened a new frontier in understanding the potential for habitability on other worlds. 26. Enceladus water plumes. The discovery of water plumes erupting from Enceladus stands as a groundbreaking revelation by the Cassini spacecraft. These geysers, shooting from the moon's south pole, consist of a fascinating mix of water vapor, ice particles, and organic compounds. Such findings hint at the exciting possibility of an ocean lying beneath the icy surface, potentially harboring the ingredients necessary for life. The images and data collected by Cassini of these plumes have not only showcased the moon's dynamic nature, but also deepened our curiosity about the conditions required for life elsewhere in the solar system. 27. Saturn's translucent rings. The translucent rings of Saturn, captured with exquisite detail by the Cassini spacecraft, are a marvel of the solar system. Composed primarily of ice particles with a smattering of rocky debris and dust, these rings vary in transparency and structure, revealing intricate patterns and waves caused by gravitational interactions with Saturn's moons. The images taken by Cassini have allowed scientists to study the delicate balance and composition of these rings, uncovering the dynamic processes that govern their appearance and evolution. The sheer beauty and complexity of Saturn's rings, seen in these photographs, underscore the sophisticated nature of celestial mechanics at play. 28. Methane clouds on Titan. The methane clouds on Titan present an otherworldly weather system, unlike anything found on Earth. Captured by Cassini, these dense, swirling clouds offer a mesmerizing view of meteorology in action on Saturn's largest moon. Formed from Titan's chilly methane cycle, these clouds scatter across the moon's atmosphere, sometimes unleashing methane rain onto the icy surface. The images provided by the spacecraft have allowed scientists to study the dynamics of Titan's atmosphere, understanding how these clouds move and change with the seasons. This exploration into Titan's cloudy skies sheds light on the complex atmospheric processes of a world far from our own. 29. Saturn's ring moonlets and waves. The Cassini spacecraft has unveiled a fascinating aspect of Saturn's rings, the existence of tiny moonlets and the waves they create. These moonlets, hidden within the rings, exert gravitational forces that shape the surrounding particles, forming wave patterns that are both complex and beautiful. The discovery of these features has shed light on the dynamic interactions within Saturn's rings, illustrating how even the smallest bodies can have a significant impact on the structure and behavior of the ring system. Cassini's images of these phenomena have provided invaluable data for understanding the mechanics at work in Saturn's iconic rings, revealing a level of intricacy previously unseen. 30. Titan's river channels. The exploration of Titan by the Cassini-Huygens spacecraft revealed an astonishing network of river channels, etching their paths across the moon's surface. These channels, carved by flowing liquid methane and ethane, resemble the river valleys on Earth, providing compelling evidence of active surface processes in Titan's cold environment. The detailed images captured by Cassini have allowed scientists to trace the journey of these hydrocarbon rivers from their origins to their endpoints, often vast lakes and seas, showcasing the active hydrological cycle that shapes Titan's intriguing landscape. This discovery not only highlights the Moon's dynamic nature, but also expands our understanding of geological and hydrological activity beyond Earth. 31. Saturn's ring-shepherd moons. The Cassini spacecraft unveiled the enigmatic role of Saturn's shepherd moons in maintaining the structure of the planet's rings. These small moons orbit within or near the rings, their gravitational influence serving to sculpt and confine the ring material, creating gaps and edges that define the ring's appearance. Captured images by Cassini of these shepherd moons, like Prometheus and Pandora, illustrate their crucial role in the ring system's dynamics. The detailed observations provided by Cassini have deepened our understanding of how these moons interact with the ring particles, preserving the ring's intricate architecture and contributing to the overall stability of Saturn's distinctive halo. 32. Titan's hazy atmosphere. Titan's atmosphere, dense and hazy, offers a unique window into atmospheric chemistry under extreme conditions, comprised mainly of nitrogen, with a mix of methane and hydrogen. This thick haze enshrouds the Moon, giving it a distinctive orange appearance in images captured by the Cassini spacecraft. The haze layers extend far above the surface, playing a crucial role in Titan's climate and weather patterns. This veil is the result of sunlight breaking down methane, leading to complex organic molecules. Cassini's exploration of this atmospheric phenomenon has provided invaluable insights into the similarities and differences between the atmospheres of Titan and Earth, showcasing the diverse conditions that can support a thick atmosphere in our solar system. 33. Saturn's ring propellers. One of the most intriguing phenomena observed by the Cassini spacecraft within Saturn's rings are the propeller formations. These features, spanning several kilometers, resemble the wake of a boat propeller, created by small moonlets moving through the ring material. These moonlets, too tiny to be seen directly, exert a gravitational pull that gathers ring particles before them and leaves a disturbed trail behind. The study of these propeller shapes has offered scientists a unique opportunity to understand the density and texture of the rings, as well as the gravitational interactions that sculpt their intricate patterns. Cassini's detailed images of these formations have illuminated the dynamic and ever-changing nature of Saturn's rings. 34. Saturn's polar hexagon. Cassini's observations of Saturn's north polar region revealed a remarkable hexagonal-shaped jet stream surrounding the pole. This hexagon, with each side stretching more than 13,000 kilometers, 8,000 miles, consists of high-speed winds swirling around a central vortex. The exact mechanism behind the formation of this hexagon remains a subject of scientific inquiry, with theories ranging from interactions between atmospheric flows and the planet's rotation to the influence of Saturn's internal dynamics. 35. Phoebe's retrograde orbit. Cassini's close flyby of Saturn's moon, Phoebe, revealed an unexpected characteristic: its retrograde orbit. Unlike most moons in the solar system, which orbit their parent planet in the same direction as the planet's rotation, Phoebe orbits Saturn in the opposite direction. This retrograde motion suggests that Phoebe may be a captured object from the outer solar system, potentially originating from the Kuiper Belt or even further out in the distant reaches of the solar system. 36. Titan's hydrocarbon lakes and seas. Cassini's radar observations unveiled the presence of vast lakes and seas on the surface of Saturn's largest moon, Titan. These bodies of liquid, predominantly composed of methane and ethane, dot Titan's polar regions and are larger than some of Earth's largest lakes. The discovery of liquid hydrocarbons on Titan's surface revolutionized our understanding of planetary bodies and their potential for hosting unique forms of chemistry and possibly even life. 37. Titan's sand dunes of organic material. Cassini's radar and imaging instruments revealed extensive sand dune fields covering Titan's equatorial regions. These dunes, which can reach heights of up to 100 meters, 330 feet, are composed of organic particles primarily made of hydrocarbons like ethane and methane. The formation of these dunes is driven by wind processes and atmospheric conditions unique to Titan, providing valuable insights into the geological and climatic dynamics of this enigmatic moon. 38. Enceladus subsurface ocean. Cassini's close flybys of Enceladus detected plumes of water vapor and icy particles erupting from deep fissures near its south pole. Analysis of these plumes revealed the presence of salts and organic compounds, indicating interactions between water and a subsurface ocean beneath Enceladus' icy crust. This subsurface ocean, kept liquid by tidal heating generated by Saturn's gravitational forces, represents a potential habitat for microbial life and has positioned Enceladus as one of the most promising targets for future astrobiological exploration. 39. Titan's methane rain and river channels. Cassini's observations of Titan's surface revealed evidence of seasonal methane rainfall, which has sculpted intricate networks of river channels and valleys over time. These methane rivers, lakes, and seas form a complex hydrological cycle on Titan, analogous to Earth's water cycle, but operating with hydrocarbons instead. The discovery of active surface processes on Titan, driven by a combination of methane rainfall, evaporation, and erosion, underscores the dynamic nature of Saturn's largest moon and its potential for geological and atmospheric studies. 40. Saturn's Great White Spot. Cassini captured images of a massive storm system known as Saturn's Great White Spot, which periodically emerges in the planet's atmosphere. These immense storm systems, characterized by bright clouds and turbulent weather patterns, can span thousands of kilometers and persist for months. The occurrence of these great white spots, occurring roughly once every Saturnian year, equivalent to approximately 30 Earth years, highlights the dynamic and ever-changing nature of Saturn's atmosphere and provides valuable data for understanding the planet's meteorology and atmospheric dynamics. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.